Hello everyone, myself Dr. Feroza de Mirajkar, and today we will see a 8051 program to convert a given BCD number to hexadecimal number. So for that, let us take a 2-digit decimal number, that is 46. So 46 is a BCD number which we are taking. Its equivalent hexadecimal number will be 2e. Now, the main logic behind converting the decimal, that is a BCD number, to the hexadecimal number is to separate the digits. That is, the most significant digit will be 4 and the least significant digit will be 6. Okay, so what is the logic here? The logic is converting a decimal number to hexadecimal number is to separate the digits of the decimal number, okay, by unpacking the digits of this given BCD number. Okay, so the most significant digit of 46 is 4 and the least significant digit is 6. Now we need to extract these MSD and the LSD. So for that, what we have to do is we have to multiply the most significant digit with 0a, and to this we have to add the least significant digit so that we get the hexadecimal number. Okay, now the most significant digit here is 4. Okay, and we have to multiply it with 0a, and the product of this, it should be added to the least significant digit, that is 6, so that we get the hexadecimal number, that is 2e. Okay, now we have to first extract the digits, that is 4 and 6, individually by process of unpacking. For that, we will take the number 46 and we will AND it with F0. So when we AND this, we get the result as 40. But we don't want 40, we want 4. That is, we want to extract the most significant digit. Now, if we swap the digits of this 40, we will get 04. So for that, we will apply a swap instruction, or we will perform a swap here so that we get the result as 04. Now this 04, it has to be multiplied with 0a so that the result will be what? The product of this will be 28. Okay, what we have done to extract the most significant digit, we have taken it, we have ANDed it with F0 and we got 40. Now we wanted 04. So for that we have swapped the lower nibble and the higher nibble. So we got it as 04. To this 04 we are multiplying it with 0a so that we get 28 as the product. Now what is the next step? We have to extract the least significant digit. For that, again we will take 46 and we will AND it with 0f. Okay, to get the MSD, we are ANDing 46 with F0, and to get the LSD, that is the least significant digit, we are ANDing the given number with 0f. Okay, now we will get the result as 06. So directly we are getting the least significant digit here and there is no need of swapping. What is the next step? We have to add the product and this least significant digit. So we have to add these two so that we get the equivalent, the hexadecimal number, that is 2e. Okay, so what we have done here, so how you take the MSD? Here you have to AND it with F0, then you have to swap the product. After that you have to multiply with 0a and this should be added with the LSD, which is obtained by ANDing with 0f, and here there is no swapping. So when you add these two, you will get the required hexadecimal number. Okay, so this is the logic to convert a given BCD number to a hexadecimal number. Now we will see the program steps. Okay, general steps what we have to perform in our program. So here the program begins by accessing the data which will be stored at a memory address. Here we'll be using the memory address as 40H. After that you have to extract the upper nibble. Okay, and that is you will get the first 4 bits um, of the upper nibble, and those will be stored at the specified memory address. Okay, then once that is done, you have to swap the nibbles, that is the upper and the lower nibbles of the byte are swapped. This means that the original upper nibble becomes the lower nibble and vice versa. Once you are swapped with the nibbles, then you have to multiply that with 10. Okay, so this is done by using the mul AB instruction, that is the multiplication instruction, which will multiply the contents of the accumulator and the register B. Then after that you have to add the lower nibble. Okay, so once you obtain the product here after multiplying with 10, that it must be added to the lower nibble of the original byte, and then you will obtain uh, the result here. Okay, that is the final number you will be obtaining here. Now that will be stored into the accumulator, then that has to be stored to a to a memory address. Okay, that is you have to store the final answer which you get here to the memory or the specified memory address. Okay, so this is about the general steps of the program which you have to perform. Now we will see the program. So here we will store the decimal number, that is input in R0, okay, at 40H memory location, and converted hexadecimal number, that is the output, will be stored at 41H memory location. Okay, so the first line is what? org 00000000H. Now the first step is to initialize the register R0 to 40H. So for that we write the instruction as move R0 comma hash 40H. Okay. Now we need to perform an AND operation in the subsequent steps of the program. So the data, that is the decimal number 46, it must be moved to the accumulator from this 40H memory location. So for that we are writing this instruction, that is move a comma at R0. Okay, so the contents of R0 are moved to the accumulator. Now we will start with our first process, that is we have to extract the most significant digit, that is the MSD. So for that we will use the instruction ANL A comma hash 0F0H, that is the data which is present at the accumulator. Okay, that must be ANDed with what? It must be ANDed with F0. Okay, here I have written it as 0F0, but while explaining I have just written it as F0. You can't write only F0 in the program because the number is starting with an alphabet. Whenever a number starts with an alphabet, you have to prefix it with a 0. Otherwise, the assembler will consider this number as an label and it will not consider this as a number. So because of that, we are prefixing F0 with 0. Okay. So what we'll do, we'll perform a AND operation and we will get the number 40. Now we don't want 40, we want 04. So we will write the instruction swap A. So the contents of the accumulator. Okay, after performing the logical AND, the result will be stored in accumulator. Now we have to perform a swap operation on the contents of the accumulator in order to get the most significant digit. Okay. So now we have in the accumulator the most significant digit. Now we want to multiply this accumulator, contents of the accumulator, with 0A by using the mul AB instruction. Now in this mul AB instruction, one of the operand should be in the accumulator and the another operand should be in the register B. So what we will do is, before multiplying, one operand already it is in A, another operand that is 0A will move it to B by using the instruction move B comma hash 0AH. Once we get this, that is we get both the operands in A and B. One of the operand is in A, another operand is in B. Now we'll perform the multiplication operation. So we'll use mul AB. Okay. So after multiplying, the result will be stored at the accumulator. Now once you are done with this, uh, after this multiplication, the higher byte it will be stored in the register B. Okay, here register B, and the lower byte will be stored in the accumulator. Okay, that is A register here, A register. So what we have to do is here we have multiplied. Now we have multiplied that is 0 4 with 10. Yes, no, 0 4 with 0A. So after multiplying, we have got the result 28. Now 28 in 16-bit it can be stored at as 0028. Okay, so already 28 is in accumulator, that is the lower nibble. Okay, the lower byte it is stored in the accumulator itself. So now we have to repeat the step of ANDing in order to get the least significant digit. Now we have got the most significant digit and we have performed the first part of the equation, that is multiplying most significant digit with 0, and that result we have stored in the we got in the accumulator. Okay, now here we again we have to perform a logical AND operation. For that 46. Okay, so for that the number it should be again we need to get 46, but we have not saved this 46 here in the previous steps. So what we have to do is uh, just a minute. Before ANDing, okay, before ANDing, for to get the LSD, what we have to do is we have to store the result, that is 28. Okay, because we need 28 in the further steps to add to the least significant digit. So that uh, that 28 which is currently in the accumulator, that should be stored at some other register. So what we'll do, we will save the contents of the accumulator A, that is 28, to a temporary register, that is R1. So for that we will use move R1 comma A instruction. Okay, now so our data that is 28, it is safe in the register R1. Here it is safe in the register R1. Now we have to extract the least significant digit. So for that what we have to do, we have to again use the logical and we have to AND 46. Okay, 46 with 0F, but we have lost 46, we didn't save it. So what we have to do is we can again point to the address 40H. Okay, and this 40H, and uh, the number 46 is, it is still in 40H. So for that what we'll do is we will write the instruction move A comma at R0. Okay, so when we write this, we'll get 46 in the accumulator. Now we can perform the logical AND operation. So after this, you have to write the instruction ANL A comma hash 0FH. Now after ANDing, we have 06. Okay, 06 will be stored in the accumulator. Okay, now and the number 28 to which the LSD has to be added, that is stored in R1. So we need to perform a add operation. Okay, So you have to write the instruction as add a comma r1. R1 consists of 28, a consists of what? 6, the least significant digit. So now when you add these two, what you will get? You will get 2e, which will be stored at the accumulator. Now we have to store the final answer. Okay, final answer is in the accumulator. Now we have to store that at a memory location. For that, what we'll do is we will increase the we will use the instruction increment r naught. Okay, so that r naught points to 41h memory location. Now once the memory location is increased, that is now r naught becomes 41h. So next instruction is you have to save your final answer, that is 2e, which is in the accumulator, to the memory location 41h. For that we will use move at r naught comma a. Once that is done, you have to stop the program by entering a infinite loop by using this instruction h colon s jump h, and you have to end the program by using the end directive. Okay, so here what we are doing, we are using first the directive, that is org0000h. Then we are using move r0 comma hash 40h instruction. Now we have entered 46 at 40h memory location, that must be moved to the accumulator. Okay, because this anl that is logical, and for that we need the data into the accumulator. Next you have to write the instruction anl a comma hash 0f0h in order to get the msd. But when you do this, you get the result as 40. So to get the msd, you have to swap the digits. So for that we'll use swap a. Once this is done, we need another operand in b register, that is we need 0a into b to perform the multiplication instruction. So for that we'll move 0a into b. Okay, then we will perform the multiplication operation, and now the result is stored in the accumulator. Okay, once this is done, we have to save our data to some temporarily address to some temporary register, because we want this in the subsequent steps. Okay, here we need it to add it with the least significant digit. So we'll save it. After that, again we'll get the BCD number here at the accumulator to perform the logical and operation. Now to get the least significant digit, the contents of the accumulator should be ANDed with 0f. Okay, here to get the most significant digit, we have ANDed it with 0f0. To get the least significant digit, we'll AND it with 0f. Okay, now you have to add the contents. So here once you do this, sorry, anl a comma hash 0f0 you will get the result stored in accumulator, that is 06. Now you have to add these two. So when you you have to add the data which you have stored in the register r1, that is 28, and here what did you get? Here you got 6. So when you add, you will get 28. Okay, now this when you add, you will get it as 2e. When you add 28 and 6, you will get it as 2e here. Now this 2e has to be stored at another memory location. So for that we will perform increment r0. Now r0 points to 41h. So now our data, which is in that is the final result, is in the accumulator. It has to be moved to the memory location 41h by using this instruction. Then we will enter an infinite loop and we will end the program. Okay, after this, at 40h memory location, you have to give the input as 46, and at 41h memory location you will get the output as 2e. Okay, now we will see the execution of the program. I'll copy the program first. So I will open the Keel software by double clicking on the icon. Now you have to maximize this. Okay, go to project, new mu vision project. I'll use the previously used project. Already exists. Do you want to replace it? Yes. Go to microchip device. Search for microchip device. Okay. So here you are having microchip. Click on this plus symbol and search for 8089 C51. Okay. And no. Okay. Now go to file, new file. Type your program here. I'll directly paste my program here. Save it. So I'll save it as B2H. Okay, because it is binary, that is BCD to hexadecimal. So sorry, it is yes, binary to hexadecimal dot ASM. You have to always save with the extension dot ASM. Okay. Now go to the target and click on this plus symbol. Right click on this source group 1. Then click on add existing files to group source group 1. Search for your program. Your program name is B2D. Okay. B2H. Sorry. B2H dot ASM, add and close. Okay, now see whether your program has been added. Yes, it has been added to the source group 1. Now go to the project, click on build target. So there are 0 errors and 0 warnings. Go to debug, click on start or stop debug session. Okay. Now go to the memory 1 window, type here I colon 40H. Okay, at 40H you should give the input as 46. Okay, so at the input is given at 40H memory location. At 41H, what you should get? You should get the equivalent hexadecimal number as 2E. Okay, 2E. Now we will run this. So you got the output as 2E. Input is 46, that is the BCD number is 46 and the hexadecimal number is 2E. Okay, I hope you have understood the program. Thank you.